Welcome! In this video, I'd like to show you some examples of polynomial synthetic division. Synthetic division can be used when dividing a polynomial by a binomial in the form x minus c. Please note that the divisor should be in degree 1 and the leading coefficient is also 1. To explain the process of synthetic division, we'll perform synthetic division on a third-degree polynomial here. However, we are not limited to only third-degree polynomials. Our first step is to list the coefficient of the polynomial and write the c value here. Here, it is critical that we use the opposite sign of c value. For example, if we had x minus 2, then c should be 2. If we had x plus 2 instead, then c should be negative 2. For the second step, bring the a value down. Then we multiply that a value by c and place it in the next column as shown. Then add down to get the sum of b plus ca. We call this sum 1. Again, we multiply the sum 1 by c and place it in the next column diagonally. Then add down to get the sum 2. We repeat the same process to the end. So the vertical pattern is to add, and the diagonal pattern is to multiply by c. The last sum is the remainder of this division. And the first three numbers represent the coefficient of quotient, which is one lower degree than that of the dividend. Since this illustration shows polynomial of third degree as dividend, the quotient should have degree 2. Let's take a look at some examples to apply what we have learned so far. Our first step is to list the coefficient of the dividend. We have 1, 8, negative 7, and 6. Next, we need to identify the c value. Write the opposite sign of the constant in the divisor. So it is 4 in this case. Unlike long division, we use the addition method in synthetic division. So we use the opposite sign of the constant here. We start by bringing down the leading coefficient of 1. Then we multiply that 1 by c, so 1 times 4 to get 4, and place 4 in the next column. Then add 8 plus 4 to get the sum of 12. In long division, you might recall that we subtract each time. However, in synthetic division, keep in mind that since we use the opposite sign, we need to add here. Again, we multiply that 12 by c, so 12 times 4 to get the 48, and place it in the next column diagonally. Next, add down to get the 41. We then multiply 41 by 4 to get 164. And we get the sum of 6 and 164 as 170. The last value is the remainder of this division. And these three numbers are the coefficient of the quotient. Since we started with a degree 3 polynomial as the dividend, our quotient would have degree 2. So the quotient would be 1x squared plus 12x plus 41. Our final answer is x squared plus 12x plus 41 plus remainder 170 over the divisor x minus 4. Before moving on to the next example, let's compare the synthetic division method with regular long division. Then we'll see how synthetic division produces the same result. We hope to see the connections between the two methods. If we use long division for the previous example, then we set it up like this. First, we need to think about dividing the highest degree term x cubed by the highest term of the divisor, which is x. Since x goes into x cubed x squared times, we write it in the x squared term of the quotient. Now we can see this 1, which is coefficient of x squared term as we drop down in synthetic division. So these are the same thing. We can drop down the first coefficient straight, since we only divide by x, not by 2x or 3x. So if you divide the highest degree term by x, then the coefficient becomes one lower degree with the same coefficient. Let's continue to compare. Next, we take x squared and multiply by the divisor x minus 4. X squared times x is x cubed, and x squared times negative 4 is negative 4x squared. Now we need to subtract this. The x cubes are cancelled out, and change the sign of 4x squared to positive. So we are left with 12x squared. And bring down the next term, negative 7x. Again, we see the same coefficient 12 from synthetic division. Remember that in regular long division, we subtract, but we add in synthetic division, since we use the opposite sign of the constant of the divisor. Next, divide 12x squared by x to get 12x, and we write it in the x of the coefficient. Let's keep going. We take 12x and multiply by the divisor x minus 4 to get 12x squared minus 48x. Again, subtract it from the above. Of course, 12x squared is cancelled out, and subtract negative 40x from negative 7x to get positive 41x, as we need to change the sign of negative 48x to positive. Then bring down the last term, 6. We know that this 41 is a part of our answer, and we can see it in the synthetic division as well. So 41x divided by x is 41, and write it in the quotient. The 41 matches with the same value in synthetic division. Multiply 41 times x minus 4 to get 41x negative 164. And we are going to subtract this from that. 41x is cancelled out, and 6 minus negative 164 to get 170, which is the remainder, and we can see exactly the same value there. Hopefully, we can see the connection. Please keep in mind that divisor must be in the form of x plus or minus some number. This method is simpler, faster, and takes less space than using the regular long division method. Let's take a look at another example. The first step is to list the coefficient of the dividend. We read the polynomial as 5x cubed plus 7x squared plus 0x minus 3. When you write the coefficient, you need to be aware of 0x. this 0 is important to write as the coefficient of missing terms. We have 5, 7, 0, and negative 3. Next, we need to identify the c value. Write the opposite sign of the constant in the divisor. So it is negative 2 in this case. We start with bringing down the leading coefficient of 5. Then multiply by that 5 by c. So 5 times negative 2 to get the negative 10. And place it in the next column. Then 7 plus negative 10 to get the sum of negative 3. In long division, we subtract each time, but remember that we use the opposite sign in synthetic division, so we add here instead. Again, we multiply that by negative 2, so negative 2 times negative 3 to get 6, and place it in the next column diagonally. Next, add down to get 6. We then multiply 6 by negative 2 to get negative 12. And we get the sum of negative 3 and negative 12 as negative 15. The last value is the remainder of this division. And these three numbers are coefficient of the quotient. Since we started with a degree 3 polynomial, our quotient would have degree 2. So the quotient would be 5x squared minus 3x plus 6. So the final answer is as shown. Let's go through another example so that you get comfortable with this process. The first step is to list the coefficient of dividend. We read the polynomial as 2x to the fourth plus 0x cubed plus 4x squared minus 5x plus 8. Again, the x cubed term is missing here, so we need to write the coefficient 0 for that term. We have 2, 0, 4, negative 5, and 8. Next, we need to identify the c value. Write the opposite sign of the constant in the divisor. So it is 3 in this case. Then start with bringing down the leading coefficient of 2. And we multiply by that 2 by c. So 3 times 2 to get 6. Next, place it in the next column. Then add 0 and 6 to get 6. Again, we multiply that by 3. So 3 times 6 to get 18 and place it in the next column diagonally. We repeat the same process. So add down to get 22. We then multiply by 22 by 3 to get 66. And we get the sum of negative 5 and 66 as 61. For the last column, we multiply 3 by 61 to get 183. Finally, add down to get 191. The 191 is the remainder of this division. And these four numbers are the coefficient of the quotient. Since we started with a degree 4 polynomial, our quotient would have degree 3. So the quotient would be 2x cubed plus 6x squared plus 22x plus 61. So we get the final answer as shown. Let's do one more. If you take a closer look at this problem, you may notice that it is not in the form that we need it to be in. Remember, the divisor has to be in the form of x plus or minus c. So it seems like we would need to perform long division for this kind of problem. However, we can divide everything by 2, and it would still not affect the quotient. So we divide every term of both numerator and denominator. Then we get the divisor as x plus half. Now we can apply our synthetic division process for this problem. As usual, our first step is to list the coefficient of the dividend. We have 4, -8, 5, and -3. Next, we need to identify the c-value. Write the opposite sign of the constant in the divisor. So it is -half in this case. Then start with bringing down the leading coefficient of 4. Then we multiply 4 by -half to get the -2, and write this in the next column. We add -8 and -2 and write -10. Again, we multiply -10 by -half to get the 5. Write 5 in the next column diagonally. Next, add down to get 10. We then multiply 10 by -half to get the -5. Finally, add down to get -8. The last value, -8, is the remainder of this division, and these 3 numbers are the coefficient of the quotient. Since we started with a degree 3 polynomial, our quotient would have degree 2. So the quotient would be 4x squared minus 10x plus 10, minus 8 over x plus half. However, the remainder part is not in the correct form because the original problem had a divisor of 2x plus 1, not x plus half. We can solve this issue by multiplying both the top and the bottom by 2. Then we get 16 over 2x plus 1. This gives us the correct answer for this problem as shown. Of course, you do not have to convert this problem into synthetic division. Synthetic division can be used when dividing a polynomial by a binomial in the form x plus or minus c. Please practice many questions after watching this video to become more comfortable with the process. Thank you for watching. See you again.